Hi guys. So sorry I couldn't be there today. The Gornling Sam is sick, and please forgive me. It is 2 billion o'clock in the morning. Okay, so yesterday we started balancing equations where we said, okay, the above equation can say one molecule of CH4 reacts with two molecules of oxygen to yield one molecule of carbon dioxide and two molecules of water, right? And we said that that relationship it can be, we could talk of it in chunks, these particles are called molecules, or you could say 1 dozen CH4 molecules reacts with 2 dozen oxygen molecules to yield 1 dozen carbon dioxide and 2 dozen water molecules. However, that said, we don't usually work in dozens, we work in moles. All right, so the relationship, you could also say that 1 mole of CH4 reacts with 2 moles of oxygen molecules to yield 1 mole of CO2 and 2 moles of water, okay? But now, here's where we get a little bit more mathy with it, okay? What if I had 2 moles of CH4? How many moles of oxygen would that take to fully use it up? You would all say 4 off the top of your head, okay? Let's see why we're doing that, okay? I said we started with 2 moles CH4, okay? So we can do this by unit conversion, and this might get a little bit sloppy, okay? That, what unit are we trying to end up with? I want to know about the moles. Ugh. This is just as painful for me as you. Okay, so this is moles of oxygen reacted. On the bottom, we want to get rid of moles, ugh, moles CH4. Okay, now, what's the relationship we know between those? We know for every 1 mole of this, it's 2 moles of oxygen that react. And so that ends up being, as you guys did in 4 seconds, you guys said, oh, well, that should be 4 moles of oxygen reacted. Okay? Now, we can also do this when there are uglier numbers involved. What if I had 4.5 moles of CH4 and I wanted to know how many, I'm going to sort of do this like this. How many moles of um, of oxygen would it take to fully react with that? Again, keeping a sort of um, a what's the word? Foot in. Ugh. keep a foot in real person land. Okay, you know that the answer should be bigger because for every 1 mole of CH4, there are 2 moles of oxygen that are reacting. Okay, so let's put that relationship in. What unit are we trying to get to? Moles of oxygen. All right, so let's grab that. We're going to put that there. Okay, what unit do we want to get rid of? Moles of CH4. Okay, now, what's our next step? We got to make sure that we're multiplying by 1. Okay, what's the relationship here? Well, for every 1 mole of CH4, we have 2 moles of that reacting, okay? So, what's that going to end up equaling? Well, if you cross out the units, blah, blah, we end up with 9 moles of oxygen reacted, okay? So hopefully that helps get you started that what we're really doing, should I just stop this right now? Okay, what we're really doing is stoichiometry now, okay? That we're really using the balance equation to determine how much stuff is reacted and how much stuff can be produced, okay? You could similarly say and go to the other side, oh, well that means 9 moles of water would also be produced because the ratio here is 2 to 2. Okay? Hopefully that gets started.